So we want to look at basic plot with ggplot. That is ggplot2 package. So inspired by a book titled Grammar of Graphics, that is where the word GG is coming from. Grammar of Graphics, GG. Written by Leland Wilkinson, Hadley Wickham in 2005 developed ggplot2 in that's 2005. ggplot2 is a R package used by most data analysts for data visualization. As you will soon see also, you will discover that the visualization with the aid of ggplot is finer and better than just our base R. That is the one we used yesterday, the plot function, just from our base R. ggplot2 is based on the grammar of graphics, and please, we need to pay attention to these keywords. Please, we need to pay attention now. Very important. We need to pay attention now. The idea that you can build every graph from the same components, and those components include a data set, a coordinate system, and geoms. I'm going to take that again. ggplot2 is based on the grammar of graphics. The idea that you can build every graph from the same component. Understanding these three components are very core to freely writing your own R code in order to visualize with the aid of the ggplot2 package. And the components are the data sets, a coordinate system, and geoms. We have several types of the geoms. We are still going to see what those actually mean. That is, the geoms, visual marks that represent data points. One thing about ggplot2 is that it's very, very easy to use. Reason being that you only create layers. So understanding the fact that you'll just be creating layers in order to visualize your data make it very easy to work with. And it adds various benefits ranging from creation of different type of plots, creation of high quality visuals, customization of the looks of the plot to combining data manipulation and visualization. So we have 4 things we want to cover this afternoon, and they are the concept, the core concepts, and those are the aesthetics, the geom, facets, labels, and annotations. So we are going to look at each of these one after the other. We shall work with the penguins data to explain this concept of ggplots. So, like I said yesterday, I said we should download the package, Parma Penguins package, because we want to use a particular data. The data were collected and made available by Dr. Christine Goma and the Parma Station Antarctica, LTER, a member of the Long-Term Ecological Research Network. I'm just giving us a background of the data we want to use. The penguins data can be accessed from the Parma Penguins package in R, which the reason I said we should download the package yesterday. So, how many of us have installed the package? Parma Penguins. I've installed it. If you have not installed the package, please, we can install it now. Parma Penguins. So, and we also need to install the ggplot2 package. So, how many of us have installed that, the ggplot2? Please, I want to see our hands so that I can know ggplot2 package. All right, it's okay. So, if you have not installed it, please, we can also do that now. Please, let's just quickly do that. Because we are going to need without the ggplot2, you can't run anything we'll be going through from now. You can't run any of it. Without the ggplot2, the Parma Penguins, or better still, if you have tidyverse. If you have installed tidyverse before now, then you are covered. You are covered. If you have tidyverse before now installed, then you are covered. Yeah, the ggplot is inside tidyverse. So if you have the tidyverse already installed, then you are covered. But if you don't have tidyverse installed, please install ggplot2. So the data set contains data for 344 penguins. There are 3 different species of penguins in these data sets, collected from 3 islands in the Parma archipelago in Antarctica. So now, why am I making emphasis on telling us some background about the data? Now, for visualization, it's very important for you to understand the data you want to work with, because there are questions you want to answer. There are certain things you want to show, possibly maybe the public health officials, stakeholders, as the case may be. You've worked on the analysis, but now you want to present the visualization of your analysis. That is what ggplot enables us to do. Having done the analysis, you want people to see the outcome of that analysis with the aid of visualization. And that is what gives you one of the rewards for your labor. That is this ability to show you've done the analysis, to answer some questions, but now you want to show forth the result with visualization. So if we have these two libraries installed, so let us just call them library ggplot2 and library PermaPenguins. So if we have these two installed already, so let's just call them forth. Library ggplot2, library PermaPenguins. And if you have tidyverse, just call library tidyverse, and with that you are covered. That has ggplot embedded inside of it. Please, are we together? Are we here? This is just to import the libraries that we need. ggplot, PermaPenguins, so that we'll be able to access the penguins data. Can I move on? All right. So if you have the tidyverse, you can also call it. If you have called tidyverse, there will be no need for you to call the ggplot2. So now the next thing we want to do is to assign that data. The data is called penguins. This is the data set. So we want to assign it to a variable named df. That df there, for me, it represents data frame. I'm representing my data. I'm assigning my data to the variable named df. So meaning that whenever I'm calling df, what I'm actually calling is the data. Please, are we following? So I've assigned penguins to df. So we can also do that. So let's see what we have in the data set, at least to have an idea of what we have in the data set. So we can run add df. This one is going to show us the first 6 rows in our data set. Add df is going to show us first 6 rows in our data set, and that's what we are seeing underneath here. Remember, I've converted this into Word so that we'll be able to see clearly. I actually prepared it, but I think this is also good. So add df to see first 6 rows of our data set. How many of us have seen the first 6 rows? So do you also see the variable names? Right? The column names. Right? So what are the column names that we have? The species, yes. Island, the bill length in millimeter, the bill depth, and we have the body mass, right? We have the flipper length. We have the body mass. Can you see that? All right. So we have about 8 column names. We have about 8 column names. About 8 column names. All right, can I continue? All right, so we have been able to see that. All right, so now, let's take for instance now, you have the data set. You want to know the number of rows and the number of columns in the data set. So you can just find that using dimdf, meaning dimension. All right? So let's run this dimdf to know the number of rows and number of columns that we have. Means dimension D. If you want to know the dimension, it's like you want to know the shape of the data. You want to know how many rows, how many columns. So, and each row represents characteristics of each of the penguin. Each row represents the characteristic of each of the penguin. That is, it gives us information about each of the penguins. Are we there? So how many do you see? 344 rows, right? Then we have 8 columns, representing 8 column names. Right? All right, so now there are other things we also want to see. So now we have it in the information about the data that this data about the penguins were collected from 3 different islands. Are we there? Were collected from 3 different islands. So what that implies is that under this island now, we should have 3 different locations, isn't it? Isn't it? So now we want to know the name of those locations. So you can know the name of those locations by typing unique. That is, you want to know the unique entries under that column name. You want to know the unique entries. There are many entries. Are you getting it now? But you want to know the unique entries. For instance, now, if you have, let's say, Benue, Ondo, Zamfara. Those are like 3 names. You can have them many times under a column, isn't it? So, but we want to know what are the unique names under this particular column. So you can use the unique. If you want to know unique entries under a particular column, you can use the keyword. You can use this unique function to get that. So unique df $highland. By using this $highland, what it means is that I'm calling this particular column. That's what that implies. So let's yeah. Yeah. So all right. So as I was saying the other time, I said everything we are doing now is very important for what we'll be doing later. So please let us follow the process one after the other and that. So we want to see the unique entries of the sex. So let's check that too. So let's see, what do we have under the unique sex? We know that there should be male and female, right? But at the same time, we have NA, isn't it? Telling us that we don't have entries for about 2 rows. And that's why you are seeing this one in here. Remove 2 rows containing missing values or values outside the scale range. Are we seeing that now? It is because we have missing value. That is why alongside the male and female, we also have the NA. Are we together? But that's not what we want to really look at for now. So let's go on. So now, this is a typical example of visualized data showing the relationship between the flipper length and the body mass. So what we are seeing here now is showing the relationship between the flipper length and body mass. Among these 3 species of penguins, we have the Adelaide, the chinstrap, and the gentoo. And we can see here now, we can see the subset of these species. This one is the Adelaide, the chinstrap, and also the gentoo. So you may have what you want to communicate with this, but the question is, how do we get to this stage? Are we together? How do we get to this stage? Maybe you have something you want to communicate. For instance now, since this is showing relationship between the flipper length and the body mass, you will agree with me that the more the flipper length, the more the body mass, isn't it? That is what this relationship is showing. That's why you are seeing it going in this direction. It's showing to us that the more the flipper length, then the more the body mass, giving us relationship between the flipper length and body mass. of the penguins. So the question is, how do we come about this? So before we move to that, let's look at the core concepts as I have stated earlier. The aesthetics, very important. The aesthetics is a visual property of an object, a visual property of an object in your plots. And that can be in terms of the shapes, can be the size or color of your data points. Please, are we together? So some of these things that I'm giving us as the background, we are still going to see them by the time we are running the hard code. It's not just about running the hard code. It's very, very important for you to understand what each of these things actually represents. Reason being that ggplot is something you build using layers. You build layers upon layers in order to have a better visualization or a good representative of your data in terms of the kind of plots you want to use. Then we have the geom. The geom, which is the geometric object used to represent your data. That can be point, that can be line, and other geometric objects. Then we have the facet. The facet allows you to display smaller groups or subsets of your data. For instance, now, what you see here subdivided into three is actually one column. Are we together? It's actually under one column. But the plot you are seeing here gave us a subset based on the species. That's given us the subset of the data based on the number of species. Let's take, for instance, if we have maybe 4 species of the penguins, that means we are going to have 4 plots on this ground here. Please, are we together? Please, are we together? Please, very important. I have to, one of the things I like to do is I like to give you a background. So by the time I'm running, you'll be able to run with me. No, I will have to run. Are we together? So that's why I'm explaining this one after the other. So that when it is time for us to take off, if you are boarding the plane, there's the point, you just be going, you will think, the first time I boarded the plane, going to Ghana, it was at night. So while we're in the plane was just moving slowly. And I was wondering, so this thing will fly like this? So just going slowly, for like more than 5 minutes. And this thing will fly like this. I said, let me wait and see. But when it was time to take off, I don't know what the pilot pressed. Zoom, before we know, we're already in the air. Amen? So, it is well. All right, so we are moving slowly now. Some of you may be wondering, is this what we are going to do? So by the time we are about to take off, we'll be able to take off together. Right? All right. So we have the geom. Okay, we have the facet. So allows you to display smaller groups or subsets of your data as I've just shown us. We are still going to do this very soon. So now, then we have the labels and annotations, which allow you to customize your plot. You want to do the labelings, you want to put the caption, you want to put the label of the y-axis, you want to put in some text and all of that. The labels and annotations help you to do that. So we are going to look at the first 4 concepts using the penguins data. So now let's get started. So you have already declared a variable name and you have assigned the penguins data to it, isn't it? Isn't it? So to start ggplot, to visualize with the aid of ggplot2 package, so the first thing you want to do is to type ggplot and put your data in that parenthesis you see, because it is a package, it's a function. So let's write ggplot df and run it, and let's see what the output will be like. You there? Just type ggplot. Ggplot is automatically inside Tediverse. So just type ggplot df. Please ensure you have declared your df. Remember, the df is data frame. We have assigned our penguins data to df. So the ggplot takes in the data, all right, and that's what we have seen here. So if you run it, you are going to have something that looks like a blank canvas, just like what you can see here. Are we there? Reason being that what you have just called is just the ggplot and the data. So you have not introduced something that gives us the shapes of your plot points. Are you getting it now? Remember I told you about the aesthetics, the geom, the facets, then the labels and annotation, isn't it? So what you have just done now is you've just called the ggplot and the data. But what is going to give us the shape of your point? What is going to map the column name to maybe the x-axis or the y-axis? You have not called that. Please, are we together? Now, and one thing is that after calling the ggplots and you have put in the function ggplots and you have put in your data, so the next thing you want to do now is you want to add layers upon layers in order to have a better visualization. And the one way to add other layers is by the plus sign. So if you want to add another layer to what we have here now, you put the plus sign, enter, then you have another thing that will be written here. So this one is different from the plot function we used yesterday. You will see inside the plot function, it is inside that parenthesis we put several arguments, isn't it? But that is not the case with ggplot. Are you getting it now? And that's why we call it grammar of graphics. So you had layers upon layers. It works with layers. And you had layers using the plus sign. So after the ggplot df, so just put plus and press enter, then it moves you to the next line on your house script. And let us now add another layer in order to have a view of what we want to do. You see? No, after the plot, just press enter. You're not to run that. Just press enter. It takes you to another line. So let's see a plot of our data. So we have entered ggplot df, isn't it? So now, so let's type this geo points and all of this. Then I will explain what each of these mean. Plus geo points. Remember we said that the geo, we have geom, isn't it? Which represents the geometric objects to visualize our data. So we have the geom points, we have geo line, we have several geo. So when we are done with that, then we can run it. No. You have to type this, please. Don't type this. You don't need this one. Please don't type what you have in red. Just this. So after you have done this, so just run it and let us see the output. So what we are trying to actually do here is we are trying to look at the relationship between the paper length and the body mass. Are we there? And you will see that the output will look like something like this. You are going to have what we call the scatter plot. So what you are doing now here, you are trying to create a scatter plot. You are going to have something that will look like this. Right? Do you have something like that? Do you have something like that? So now, that is not just there. It's actually showing us a relationship. Are you getting it now? So you can see that there is a kind of linear relationship between the flipper length and the body mass. So the more the flipper length, the higher the body mass of the penguin. So meaning that the flipper length contributes to the body mass of the penguin. Are you getting it now? Remember, very important, one of the things you are doing with the aid of your data visualization is that you are trying to tell story about your data. You are trying to give us insights that we couldn't see before now with the aid of your data, and you are doing that using basic visualization. So now, let me quickly explain. Please pay attention, very important, very, very important at this time, so that we will not be making some mistakes. So having called the geopoints, which is going to represent the geometric object to represent our plot points. So we use geopoints. So then inside this geopoint now, we make use of the aesthetics function, which is represented as AES. So what is the function of this AES? Please, let's pay attention now. The AES helps us to map the column names that you have inside your data to axis of the coordinate system. Are we together now? As you can see from this place, it helps us to map. Basically, it helps us to map. And you know, when you say mapping, you are assigning an object to a particular one, isn't it? That's just mapping. So here now we can see that the flipper length is mapped to the x-axis with the aid of the AES function, and then the body mass is mapped to the y-axis, isn't it? So, and one of the things we need to understand when you are using the AES is that the AES takes in column names. Are we together? It takes in column names. That is, column names from your data. Column names from your data. That is what the AES takes in. We are going to see a typical example now. You will see that when you did the plot of from what you have now, you will see that the color of those dots, they are all black, isn't it? Isn't it? So let's assume that maybe you want to put color, for instance. You want to add color, for instance. Let's see what that is going to be like. Let's say we want to make the color to be blue. Are we there? We want to change that color now from black to blue. I want to put that in the AES function. So let's see how that's going to look like. We have color equals to blue. So can you go on and do this and run it, and let's see what the output will be like. In plot function, you use COL, but in ggplot, you write COLOR. ggplot is a different ballgame. So put that as blue and run it. If it gives you blue, I will be shocked. I'll be surprised if it gives you blue. Yes, I'll be surprised. So it shouldn't give you blue. It should give you red or other color, default color. Now pay attention. Pay attention so you can understand what I was trying to emphasize. Pay attention. Now, the aesthetic function is not seeing that blue in your data. So it cannot match it to any variable name in your data. Are you with me now? It's just seeing that as just a constant. And because it could not see that in your data, what happens is that it just gives that a default color. And that's why you are seeing another color entirely. Are you getting it now? Are you getting it now? I was trying to explain the fact that if you are using the AES function, it helps to map. It helps to map the column name in your data. It maps it to your plot point. Let's now take, for instance, I want us to see something now. You know, we have the species column name in the data, isn't it? We have species in the data, isn't it? Please, are we together? Please, are we together? We have species in the data, isn't it? Now, and under the species, how many unique entries do we have? How many unique entries do you have? We have 3. Now, if I map the color to the species, are you with me? Let's see what is going to happen. So because I'm mapping it to a column name in the data, I don't need to put it in quotes. So I'll just write species, because species is a column name in our data. Are we there? And it has 3 unique entries. So let's run this and let's see what the output will be like. Let's run this and see what the output will be like. Are we seeing the difference? Are we seeing the difference? So even though it has done the coloring by default, what has happened is that it takes each of the species, are we there, and assign a color to them. It could take those species because in your data frame you have species. Are you getting it now? And you will also see that beside the plot, you have a legend. Can you see the legend there? You will see species, then it will give you the order of the legend. You have the Adelaide, you have the chin strap, you have the gentle, and also the color, isn't it? Reason being that it has done that for you because it has mapped each of those species to a particular color. Unlike when you assign your own color and you say blue, it's not saying that from the data. It could not map it to anything. It's just saying it as a constant, so it could not map it to anything. And because it's not saying as a data, as a column name in your data, you could not find it in your data then. You just render it in a default color. Please, are we together? Please, are we together? All right, so let's continue. I'm still going to explain this more and more later as we continue. So we got this as our output. So now we said let's verify the number of species. So we have been, so if you want to know the number of species, we can do that by just saying unique df species, right? To know the unique species. And and I say we can assign unique color to each of these species. Are you seeing that now? We can assign unique color to each of these species by saying, okay, to the color, assign species. Are you getting it now? And that was what you have just seen in your output. Each of those species is represented, the plot point is represented by different color. Please, are we together? Can I continue? We have already gone past this. Can I continue? Please, are we getting the whole thing little by little? All right. Now, one thing is that because this is quite new to us, please let's pay attention. Because this is quite new to us, we may not be able to have the full grasp of what I'm explaining. Are you getting it now? But as we practice over and over, then some of these things become unfolded and become clearer to us. So let us not be taken aback if you are not getting something so clear now. All right? Over and over as you practice, you will get some of these things. So please let us be encouraged. Are you encouraged? Are you encouraged? All right. So, and we have just seen this. So now, the next thing is we can render the plot point as shapes based on the different species of penguins. Are we together? You know, we have rendered the penguins now. Different species takes different color, isn't it? One species take one color, another species take one color, another species take one color. So now, the plot points, are we there? Remember, yesterday we talked about point character, isn't it? Where you can have it as star, you can have it as triangle, depending on the number you chose, from 0 to 25, isn't it? So the same way also, we can assign different plot points to different species. Are we there now? And that we can do by saying shape equals to species. Are we there? Shape equals to species. So with this now, we are going to see different color and at the same time, different shape. We can include this size equals to 1.52. We are going to see this one later. So let's just do this. Shape equals to species. Then after that, I'm going to give us an exercise to carry out. Are we seeing the output? There's a mistake somewhere. Okay, maybe Please, any of the Camden interns should please come and assist. This person needs assistance, please. Ma? Red and green are clustered together. Are they the same shape? Yes, that's the way. So we have different shapes, isn't it? Isn't it? Now, one thing is that if you look at this, if you look at this red and green, they are clustered together normally, and the blue are somehow separated, isn't it? There are some now. One thing is that now, please let's pay attention to this. One thing is that let's say, for instance, you want to write story. There's something we call data story, all right, where you write about what you have found out from the data, and you want to tell it as a story. Is that one taken out? All right. So, for instance, now maybe if you are telling a story about the data, you want to give us some things that we are not seeing about the data. If you look at this very well, you will see that the gentle have more flipper length than Adelaide and chain strap. Do you notice that? Do you notice that? They have more flipper length. Their flipper length is longer than other species, the gentle species. Please, do you see that? They have a longer flipper length compared to the other species, isn't it? And as a result, they also have higher body mass compared to other species, isn't it? Now, pay attention. If we have left everything as black, you won't see this. True or false? So, that is why aesthetics help us to see what we wouldn't have been able to see without the use of it. Are you getting it now? All right. There are some other things we are still going to see as we explore the data more and more. Can we continue? Can we continue? Because whatever it is you are actually doing is because you have questions in your mind that you want to answer. And as you are trying to answer that question, you want to visualize your results. Let's take, for instance, maybe you want to ask that, okay, among these three species, which of them seems to be weightier compared to others? Are you getting it now? So, with the aid of this visualization now, you are able to see that with respect to their flipper length. Are you getting it now? But there are still other things we are going to see. But before we go to see that, I would like us to do something. Now, we were able to distinguish between the species, between the penguins, according to their species, isn't it? Please, are we together? Now, I want us to have a plot that also differentiates them according to the islands where they were found. Please, are we together? We want to look at the relationship between their flipper length and body mass. Are you getting it now? But this time around, I want us to have the plot point to show us, to differentiate them according to the locations where they were found. Please, are we together? For instance, what we have here now is just the word blank something that we couldn't really say much about. But here now, we are able to see these three species. We are able to see the penguins according to the number of species, isn't it? Isn't it? So now, I want us to be able to see these plots, all right? But this time around, according to the highlands where they were found. Can we go on and do that? Oh yeah, please, let's try that. Let's try that. I want us to map their color according to the highlands where they are found. According to the highlands. What? We can't see what? No, I don't need to show any code. We have written some codes, isn't it? So now I want you to, so now if you want to know, I think there are some things you can do. Okay. I'm coming. Trying to check something. Are we there? Do you have any results? You said? And what data do you have? Highlands, isn't it? So now, what can we do? I will just remove this and put highland. Are you getting it now? If I don't need the shape, I remove this. So if I should run this now, it's going to give me the same plots. Are you getting it now? Different colors, but this time around, according to the highlands where they were found. Are you getting it now? The previous one was according to the species. Are we there? This one now, according to the highlands. Are we there? Are we there? So you'll be able to distinguish, oh, this particular set were from this island, this particular set was from this island, this particular set was from this, were from this island. I'm just showing us all of that, depending on the kind of question you may have in mind concerning your data. All right? So now, let me just explain, what do I mean by this size? This size is the size of the plot points. Are we there? You will see that this size now, I didn't put it in the AES function. Please, are we together? I didn't put it inside the AES function because this 1.5 is not a variable name in the data. Are we there now? So that I just put outside the AES. So this is going to give size to our plot point. If you reduce this to 1, for instance, you will notice that the size of the plot point also will reduce. We can check that. Please, all these things, check them. Check them. Check these things as we're talking about it. Check these things as we're talking about it. Yes. The highlands and the species. The island and the species. Yes, we can actually have that. We can actually have that. We can actually, we'll still come back to that. Because if you want to have the island and the species, the way it is rendered now will not actually be the way it should be rendered. Are you getting it now? Because in the real sense, if you have to have the island and the species, the way it should be rendered should be, it picked the first island, let's say Dream. Are you getting it now? Then Adelaide, Chinstrap, Gentoo. Then Bosco, Adelaide. Are you getting it now? We are still going to see how to do that before we are done with this with the course. I just pray that the time we allow us to do that. Please, are we together? Can I continue now? All right. So we've been able to see this. Yeah. So we can also visualize the data in black and white using alpha in the aesthetics argument. This returns varying degree of transparent plots. Please, are we together? So we have, now we want to use alpha. What will this alpha do? This time around, we have removed the color species, but let's see what this alpha is going to do, and we have the size to be equal to 1.5. So I want you to go through this one now. This one gives transparency to our data points. It varies the transparency. You remember that the other time we just have it as all black, isn't it? Please, are we together? We have it just as all black, but let's see if we put alpha equal to 0.4, size equals to 1.5. Let's see what it's going to be like. That one is outside the AES. What is going to happen if we put it also within the AES? So let's do that quickly. We have removed color. Please, one thing is that some of these things, don't be editing the first code. It's better you copy that one, put it on that line, and edit. That's the best thing. And be adding comments. Be adding comments. That's the best way. If you are editing the same line of code, by the time you are done, you only have the last line. So all the previous thing gone. Did you get what I'm saying? So it's better you copy and paste. You know, it is just because of time. What will have been most appreciated will be for you to type everything over again. ggplot, data equals to this equals to this, so that by at the end of the day, you would have mastered how to really go through these things without having to copy and paste. It should have been at your fingertips. But because of time, we will not be able to really do that. So we have alpha equals to 0.4. It's just telling us the varying the degree of transparency. If you increase it to 0.9, it will be more thicker and darker. If you decrease it to 0.2, it will be more lighter. So it takes value from 0 to 1, just like degree of transparency. And then the size, 1.5, we can take it as 2.0. So the more we increase the size, the more the size of the plot point also become. If you say 2.5, it becomes bigger. But it is always better you use a size that gives us a good picture of the data points, so that it is very easy for us to read it. So what do you have? You should have something that looks like this. Do you have something that looks like this? You should have something that looks like this. Are we there? So you have plotted the scatter plots. I mean, this is a scatter plot, and you are trying to differentiate in terms of. Okay, so do we have it now? Can we continue? So that's what the alpha does. It helps us to vary the degree of transparency of the plot points. That's just what it does. Alpha. Can we continue now? Please, we have to be fast. We have to be fast. We still have a long way to go. Right? So now, one thing again is that, the other time we just have everything all black, isn't it? So let's assume that we are not interested in differentiating between the species. You want to change the all black to all blue, for instance. I told you that you can't use that color in the aesthetics function, isn't it? The way to do that is to use that color outside the aesthetics function. Are you getting it now? Remember, when you use the color inside the aesthetics function and you assign a value to it, maybe blue, it did not give you the blue. Rather, it gave you a default color, isn't it? But actually now you want it to be blue or you want it to be red, as the case may be. Then you can do that outside the aesthetic function, which is the AES function. So you have alpha equals 0.2. I've decreased the transparency. Okay, the GIT. Okay, please, our interns should come and ask. Please, if you need help, just raise your hand. Very important. If you need help, raise your hand so that people can attend to you. If you need help, please just raise your hand. Just raise your hand. Please, our interns, we need to assist people now, please. All right. So I'm not saying that you can change the color of the plot points. Maybe just from transparency, depending based on species, you can just change this to all be red. And that you can do by putting the color argument outside the AES function. So, and that is exactly what I've just done here. So I have the color now to be equals to red, the size equals to 2, which is going to be more bigger, then the alpha equals to 0.2, which will be more fainter. To be fainter, rather. So please, let's check it out and see what the result will be. So like for instance now, like this one now, you can change the color. You can write this as a comment on your next code. Yes. It's still the same. Without the data, it will still work. So we have 1 minute to be done with that. But we need to move. Still have a long way to go. So how many of us are done with that? Very few hands. It's like people at the back are not with us. Okay. So do we have all the plot points all red? Right? All red. But this time around, faint red because of the alpha. Are you getting it now? Now, increase the value of the alpha to, say, 0.7. Increase it to 0.7 and see what the changes will be like. Right? You see, it will be much, it's sharper now compared to the previous one. All right? So, let's continue. So that's what we have here. You have the alpha giving us the varying degree and all of that. 3 more minutes. Okay. Okay, so let's say another function. So now, let's make use of. Have I got in here already? Okay, so now, so far we've been able to see how to make use of the AES. All right. We can include shape, we can include color, and outside this, we can also still bring in color and size. Now, let's see another geom function, which we call the geom smooth. What do we call it? The geom smooth. What does it do? It aids the eye in seeing patterns in the presence of overplotting. Let's pay attention. What we have here now is overplotting, in that at one point, let's look at this line 180. Can you see line 180? This point 180. Can you see that we have different plots on that same line, isn't it? So now, what this geom smooth helps us to do is, one, it helps us to see trend in the data. Then two, it gives us a best fit. It gives us a best fit, which is just like a line fit, the best line fit to our data. So let's see how that look, how we can do that. Now we have used, because this time around now, we are not interested in just having a scatter plot. Are you getting it now? We want to plot a line. We want to fit a line to our scatter plot. A line, just like what Mr. Idowu took us this morning. Fitting a curve, fitting a line to a set of data, isn't it? So with the head of the geom smooth now, we want to fit a line to our scatter plot, which is going to be a best fit to this scatter plot that we have here. And that we can do making use of the geom smooth. And that is what we have here. So we can have the geom smooth. We use the mapping again, x to the flipper length to the x-axis, body mass to this. We change the alpha to be 0.9. The line width, because it's going to be a line, it's going to be a line that is being fitted to our scatter plot. It's going to be like we say, let the line width be equal to 1. Let the color of it also be blue. So let us run this and see what the output will be like. So we have used geom points. This time around, we are using geom smooth. At another time, you can use geoline. Maybe, for instance, if you want to plot cases of... yes, it's outside AES. Yes, it's outside AES. Sir? Line LWD will not work because this is ggplot. not the usual plot function in base R. So let's do this, then we can wrap it up at this junction. So let them just have result, then they can. So what have we done here? Because this geom smooth is going to come up with a line, a straight line that is being fitted to our scatter plot. So what do you have? No result. So you're going to have something that will look like this. So as you are doing that, the assignment I want to give us, yes, the assignment I want to give us now is this. You know, like as I have told you, very sorry, just the assignment that are random. So as I have told you, now we are seeing the geom smooth, isn't it? And if you look at the result of the geom smooth, it just gave us the line and the confidence interval. But I want us to do something. As I have said, let's assume we want to plot another thing still on this same canvas. Are you getting it now? What we just need to do is to bring in plus and add another layer. Are you getting it now? So the other layer I want you to add now to what we have here currently, now, I want you to add the scatter plot we had before. I want you to add that to this place now. And that's going to just be using geom points and the other things that follow. Please, are we together? Are we together? Yes, I want you to add the scatter plots to this geom smooth such that the output will be the fit and the scatter plot. And with us, I want to say good afternoon.